We are Rusma Capa, and we are about to present the first deliverable of our final project, that is the 3D printer filament machine, a device which its main purpose is to take pieces of PET and turn them into filament that can be used in a 3D printer.
So the first part is identifying the opportunities of our product of getting into the market, in this case the user, and we compare it to the process of our filament machine. For this process we're making the plastic filaments merely for the 3D printer in the TEC de Monterrey, but also putting potential users for the future. We made a horizon chart that includes 3 levels of opportunities. The first one includes all of what we currently have planned for the machine. For instance, low maintenance cost, to be eco-friendly, ergonomic, easy to use, high-tech, and good quality. The second part includes the path where we can potentially expand our product, for example, to automate the machine, to reduce operation costs, to make it space saver, and another option is to have powder instead of granulate raw material. And for horizon number 3, we have an area that we haven't explored yet, which include maybe a new, more efficient process to make filaments. Also, 4D printing can be an interesting way of creating new things.
The background of this project is the great growth of 3D printing technology nowadays that will continue like that. This situation brings a lot of opportunities in this emerging market, and according to iSmithers report, the money generated from this market will grow from a 5.8 billion in 2016 to a 55 billion by 2027. And as you can see in this graphic, the 3D printing market size has been growing in an exponential way. For these reasons, and also because we have 3D printing machines in the lab, the idea of building a machine that makes filaments for that 3D printings was born. We want to resolve the waste problem that printing plastic implies, and also the high cost that it represents, because when you're working in some prototypes of 3D printing, you make a lot of mistakes and you need to use a lot of material, so that process increases the cost in a very considerable way. That's why we developed this idea. But making our research, we found some similar concepts from other companies and also from the Columbia University. But the problem was that all the clients in the web were complaining about the high prices of these products, that they were not worth it. So we are trying to use our benchmarking and reverse engineering tools to make a competitive, functional and economic product. But our main scope are the universities and the developing departments of technology companies and industries.
In order to get the right development of our project, we create serial charts to manage the actions we are taking to get the machine. The project charter is charge of setting basically the main topics about we need to take care on. Starting with the project description, followed by the benefits and propositions, the key business goals, primary and secondary market, assumptions and constraints, and also the stakeholders interested in our project. All of these topics are described by our own ideas of what we need to assume as priority in creation of the full project. The schedule takes an important place, because we have deadlines we have to take care and comply. We starting on February check out our planning in different points of the semester in order to get progress before the final delivery arrives. March and April we're basically planning and prototyping, but the next weeks, despite of the contingency, we pretend to start manufacturing the machine where the filament will be developed.
We base our design in an extruder machine with smaller dimensions composed by a motor, a fan, an infinite screw, a hopper, and in the end of the machine there will be a reel where with the help of a coil the filament will be wounded. It is crucial for the project that the tip of the machine, where the PET will be expelled, follow the specifications of the filament that the 3D printers that we have in the workshop need, specifically the size.
For our project we have 5 main ideas. The environmental, that we want to use recyclable PET to get ABS material for the 3D printers, and also this is eco-friendly. The economic, we want to do a machine with a low price, with a low maintenance cost, with a low cost of the parts, and also the operation. The life, we want to do it resistance with a long life and also with wide range of uses. The use, we want to do it easy to use, easy to manipulate, like if we want to get this machine to other place, to transport it. Also the smooth performance that the job is well done. And also the design, we want to have a modern design, ergonomic, with a high-tech use, and also that it saves a lot of space. This is a functional analysis diagram that it first has the operational requirement, that is make a filament of recycled plastic. The first step is the electricity. This goes to the fan because electricity gives power to the fan, and also fan consumes electricity. The fan goes to the motor that it chills the motor. Also the motor gets electricity and consumes it. Then the motor goes to between the hopper and the endless screw because it melts the raw material with heat. Also the hopper gives the source of material to the endless screw. When it's melted, the motor rotates the endless screw so it can go to the extruder. And one of the risks there is that the plastic doesn't solidify before it gets to the extruder. The extruder molds how we want the filament, and also the extruder goes to the coil that it roll-ups the filament.
Our project, more than giving sustainability to a market as 3D printing also helps the environment, is something that this day is crucial for collective improvement. The planning that has been carried out throughout this work is something that in concrete way it generates innovation and serves to develop an idea in clear and consistent way. Thanks to our career, it is our duty to devise and follow up on it. The idea is only part of the result. The path is the most important thing.